Hi everyone, am I audible? Audio, video, everything is fine. Let me know. Okay, so we will start the revision of code optimization. So we have already seen live variable analysis, okay, availability expression analysis, common sub expression elimination, code optimization techniques that we have in GATE exam syllabus. All those techniques we have already seen, okay. So now let's start. So let's start the revision. First we will see the revision of live variable analysis. You already know what is this because on the Go Classes YouTube channel you can find the code optimization playlist. Okay, so so basically today we will do the code optimization in compiler design. Okay, so this revision we will do. So I am not going to teach you any concepts that I have already taught. Okay, so any concept that I have already taught, that I will not teach you. I will take some examples. Okay, so basically we will do revisions, overview of the concepts, and we will take many examples and we will solve them. Okay, so you can go to the Go Classes. So you can notice, so Go Classes YouTube channel you can go. Okay, so on that YouTube channel you will find the code optimization playlist. Okay, so basically Go Classes YouTube channel. Okay, so Go Classes for GATE CS. Okay, so this is the YouTube channel. This is okay, so you can notice on this YouTube channel you will find the code optimization playlist. Okay, this playlist you can watch. If you have not watched it, then you can watch it. Okay, so first you watch this playlist, then you watch this video. Okay, so now let's see what is live variable analysis. You already know. So live variable means a variable which is used, okay, after it is defined. For example, this variable z. Okay, if you are going to use it, then it is called live variable. Okay, so this variable z, when we will call it z, when we will call it live, when it is used. Okay, so this is the point. Now again, very important point, that use. Okay, so use of variable. So I told you, what do we mean by use? Okay, use simply means reference. Okay, use also means reference. Okay, and that means read. Okay, so use, reference, read, all these things are same. Okay, so when you do the read, then when you read a variable, okay, basically when you read a variable means you are not writing a variable. Okay, remember, not writing a variable, not changing. Basically you are just reading. Okay, not changing. So all these things they are same. Okay, and I told you sorry, I told you define also means write. When you write a variable, then it is also called define. Okay, some authors also call it kill. Okay, some people also call it kill. Similarly, some people call it use as gen. Okay, so I will tell you what this means. Okay, so this I will tell you, don't worry. Okay, so these are different names. Means basically when you write a variable, okay, when you change the variable, when you change the value of the variable, so when you write a variable, okay, that is called defining a variable. Okay, also it is called kill. Okay, so for example, you can notice here, if I give you one statement, for example, let us assume x equal to a plus b. So here you can notice what are the variables we are using. Let's assume this is the statement. So what are the variables we are using? Okay, what are the variables we are using? Can anyone tell me? What are the variables we are using? So here the variables that we are using is a comma b. Variables, okay, remember this means read. All these things are same. Read, use, reference, gen. Okay, gen means generate. Okay, this gen means generate. Okay, so don't. Okay, so now similarly in this statement, what we are going to kill, what we are defining in s. Okay, that automatically means what we are writing in s. Okay, automatically means what we are killing in s. Okay, so what we are defining in this statement, we are defining the variable, x. Okay, so we are defining this variable because we are changing this. Okay, so this is called definition and these are called use. Okay, so these are called use. Definition means this is definition means write. Okay, So this is the whole point. Okay, so so this is the point. Now similarly, if I give you this statement, x equal to x plus y, okay, then here what we are using, so what we are okay, this is your statement s, then what we use, then again we use x comma y, okay, and again what we define, we define x. Okay, so this is the point. So you can notice use comma define, okay, this is also called gen of, okay, and this is another name for this is kill of s. Okay, so basically which variables this s is generating and which variables this s is killing. Okay, so the point is that they need not be disjoint. Okay, so you can notice this x is generated also and this x is killed also. I can say this x is used also, so this is the use, and you can notice this is the definition. So here first of all you can note, here you can note that, okay, this for, okay, this use comma def, okay, they need not be disjoint. Okay, so you can notice use of s comma def of s need not be disjoint, need not be disjoint. Okay, so this is the whole point. Now now let's see what is the definition of live variable. So can anyone tell me what is the definition of a live variable? So when we say that a variable is live, so you can notice at this point, at this statement, at this program point p, okay, what can I say, which variable is live? My question is this, okay, at statement p, okay, or I can say at point p, at statement, or I can say at point p, okay, is v live? This is my question, is v live? Okay, just tell me this is my question, is v live? Is this variable v live? Okay, tell me. Okay, so these are the three, so tell me, is v live? At this point is v live? So remember, when we say that a variable is live, what it simply means, it simply means that you are using it. Okay, so basically if you have a statement, let us assume you have a statement s. Okay, now this is your statement s, and now we say that, okay, when can we say that v is live? Okay, when can we say that v is live here? Okay, what that means? So v is live, what that means? So v is live as at, okay, so what is that scenario? So this is what I am asking you. So what do we mean by v is live? So for example here, tell me what is the, okay, so you can notice in which diagram, tell me at program point p v is live, at which point, in which program p1, p2, p3, in which program? So you can notice here at this point, you can notice that we are using this v on this path. Okay, so on at least one path we are using this, yes or no? So I can say that here definitely it is live. So you can notice here, this is the use, so if you are here, okay, if you are here, then you can notice you are using this variable v, in future. Okay, at least one path, okay, to at least one path you are using this variable v. So here I can say that v is live. So here at this point I can say that v is live. Okay, and you can notice that, okay, you can notice in future there is no path where we are using v, there is no path. Okay, so you can notice this is definition, and you can also notice this is definition. Okay, so this is definition, and you can notice this is also definition. We are not using v in future. Okay, if you are here, we are not using v, here, we are not using v here, we are not using v. So that is the reason I can say here v is dead. Here I can say v is dead. Okay, and what about this? Here, if you are here, then you can notice you are using this v, that's the point. Okay, so if you are here, then you can notice that in the future we are using this v. So I can say that here v is live. Okay, so this is the point. Is this clear to everyone? Okay, this is clear now. So this is the whole point. So this is the definition of, so here v is live at p, and here v is not live at p, and here v is live at p. Okay, so this is the point. Now what is the diagram for v is live? If I ask you, this is my question. Okay, or I can say v is live diagram. Okay, so this is my question. Variable a is live. Oh, let me write. Okay, variable a is live. Okay, so this is some variable a, and now this is my diagram, variable a is live. So what will be the diagram for a variable a is live? variable y. Okay, variable y is live. Okay, so what is that? What that means? Variable y is live at state at point. Okay, variable y is live at statement s, at point s, at point s. Okay, so what that means? Now it means that you are, okay, this is your statement s. Okay, so what it means that y is live at s, what it means? It means that there is at least one path. It means there is at least one path, okay, where you are using this s. Okay, where you are using this s. Okay, remember, on the other path you can define, on the other path I don't care. For example, here you can define, I don't care. Here you can define as, okay, here, sorry, where you are using this y. Okay, here you can define this y, I don't care. But you can notice there must be at least one path. There must be at least one path. For example, here, okay, so there must be at least one path where you are using this y. Okay, so there must be at least one path where you are using this y. Okay, without, okay, so here in this area you should not define. So remember, in this area, okay, no definition. Okay, no definition of y. Here no definition of y. Here no definition of y. Okay, so in this situation we will say that y is live at statement s. Okay, so this is the point. Now when we can say that variable is dead? When can we say variable is dead? So variable a or variable y is dead at s. Okay, what it means? It means that on all the paths, okay, this type of situation is happening. Okay, on all the paths. For example, here you can, okay, here you have definition of y, and then you can have use of y. Okay, or here you can have or here what you can have, here you can have definition of y. So okay, so this is the situation. So on all the paths, basically there is no path where you are using this y. This is the situation that y is dead at s. Okay, so this is the point. Now you can notice I told you very important point. What is the most important point? When we say live at an instruction, it automatically means live just before that instruction. Okay, so live at instruction means live just before that instruction. Okay, so for example, here you can notice what is live at point n. What is live at n? Live at n simply means, this is simply means, okay, what is live just before this point n. Okay, what is live means what is live here. Okay, so this is the point. So what you can say, if you are standing here, then you are using x, you are using y, you are using s comma t. So these variables you are using. Okay, if you are standing here, then you are using x, y, s, t. So these variables you are using. So we can say that these are the live variables. Okay, so live at an instruction automatically means that live just before that instruction. Okay, so these equations we have already seen in the last lectures. So these equations, do you remember? In, okay, how can we calculate in live of n? So what is the in live of n? So you can notice this, if this is your statement n, so this is your statement n, I can say, let us assume this is your statement n. So this is your statement n. Then you can notice that this, okay, this is called in live, this is called in live of n, and this is called out live of n. And okay, and I told you that in live of n, this is same as, okay, in live of n, this thing is same as live at n. Okay, so live at instruction, live at this instruction n automatically means what is live just before this instruction. Okay, so what is live before this instruction, what is live after this instruction, and what is live at this instruction. Live at this instruction automatically means that what is live before this instruction. These two things are same. So this is what I am saying. Okay, these two things are same. So this is what I want to say. Okay, so now you already know what are these equations. I have already explained. Okay, so if you want to find out what is in, okay, so these equations, in live of n is equal to out live of n minus definition of n, like which variables are defined, okay, and union what are variables which are you are using. Okay, and out live of n, that is union of all the successor. Okay, in live of all the successor. Okay, so these equations you already know, these we have already seen these equations, and these equations are very important. Okay, so all these things that we have seen so far, this is the overview of liveness analysis. Okay, so remember very important points about liveness analysis. What are the important points? So let us see what are all the important points, all the important points of liveness analysis. First of all, this is backward analysis. You already know this is a backward analysis. Okay, so first of all, this is backward analysis. And the second, okay, what is the second point? So second point is, okay, for any statement. Okay, so you can notice for any statement n, we define. Okay, so we define these things. These are the terminologies we define. First is what is use of n. Okay, this is also called what is reference of n. This is also called what is generate of n. Okay, and this is basically set of variables which are used at this statement n. Okay, so this is the variable set of variables used. Okay, so this is the set of variables used. Correct or not? So this is the set of variables used. Okay, read, or you can say used at statement s. Okay, so this is the point. Next point is, what is the next terminology? So what is the def of n? What is the def of n, or you can say kill of n? So what is the def of n? So you can notice another is what is def of n. So what is def of n, or you can say what is kill of n? Okay, that is what, that is set of variables which are wrote at s. Okay, which are modified. Okay, which are wrote or defined, or you can say wrote. Okay, or you can say assigned, at s. Okay, so these terminologies we have. There is something called this terminology. Okay, this terminology, and similarly what we have, we have something called, okay, so after these terminologies we have something called in of n. Okay, so in live of n, or you can say simply in of n, and that is set of variables which are live just before n. Okay, so this is set of variables, this is a set of variables live just before n, okay, just before n. Okay, and this is same as what is live at n. So both these things are same, you already know. So all these things, they are same. Okay, now what else? Just wait. Okay, so what else we have? So next we have something called out. Okay, what is out of n? This is also wrote as out live of n, and this is set of variables live just after n. Set of variables live just after n. Okay, so these are some points. Now you have these equations, and these equations are very important. So what is in of n? In of n is simply what is that? In of n is simply out of n minus what is, okay, what we are defining on n, okay, union what you are using, what variables you are using. So this equation is very important. Another equation that is important, that is out of n, that is union of all the successors, union of in of all the successors. Okay, union of in of s, where s belongs to successor, where s is a successor of n. Okay, so these two equations are very important. Okay, and you can notice that live of n means live at n, that is simply same as in of n. Okay, so these are points. Now let's see some examples. Okay, I told you that when you have a context-free control flow graph. Okay, control flow graph. When you have a control flow graph without any loops, then what we need to do? Okay, without any loops, then what we need to do? So if you have a control flow graph without any loops, so control flow graph without loops, or you have a basic block, Okay, in these two situations, all you have to do, how to do analysis? Okay, how to do liveness analysis? How to do liveness analysis? Can anyone tell me how to do liveness analysis in this case? When you have basic block or you have, okay, control flow graph without loops, then how to do liveness analysis? Very simple. Okay, single backward. Okay, so that is, okay, single backward. Okay, you can say, okay, single backward propagation basically. Okay, so all you have iteration or single iteration in backward direction. Okay, so basically single iteration, all you have to do is single iteration in backward direction. Okay, all you have to do this. Okay, single iteration, you don't have to, only one iteration is needed. Okay, so you already know, only one iteration, only one pass needed. Okay, now can anyone tell me, for example, this is a control flow graph without loops. Okay, now I am saying that, let's assume this is given to you. Okay, this is given to you. What it means? It means that these are the variables which are live at the exit of this control flow graph. Okay, what are these? These are the variables live at exit of this CFG. Okay, this CFG. Can anyone tell me, is it possible? Can anyone tell me from where this XY are coming? Like at the exit of control flow graph, how can variables be live? This is my question. At the exit of, this is my question. At the exit of control flow graph, how can some variables be live? Tell me. At the exit. Tell me. At the exit of a control flow graph, how can some variables be live? How is it possible? How is it possible that some variables are live? How is it possible? Tell me, can anyone tell me that some variables are live? Some variables may be live. Can anyone tell me? Anyone want to try this? Is it okay? How can it be possible? Like this is control flow graph. Okay, this is entry. So from here you start, and this is exit. Okay, so this is the exit node. How is it possible that some variables are live here? Like, are we going to use them somewhere? Okay, so okay, how is it possible? How is it possible that some variables may be live? So can anyone tell me? The answer is very simple, and the answer I have already explained the answer. You just have to find the answer. Okay, so can anyone tell me how? Okay, how is it possible? So if you think maybe they are used somewhere, but how can they be used somewhere? Maybe they are used somewhere, but how can they be used? Okay, the answer is they may be used somewhere. They may be used somewhere. They may be used somewhere. But where they can be used? At the end, at the exit, where they can be used? They may be used somewhere. But my next question is where? Where are they used? Can anyone tell me? Yes, very good, Sudeep. Very good. Excellent. Okay, because maybe they are used in some other function. This is what I told you. For every function we have a control flow graph. Okay, so you can notice that for every where they are used. So this is my question. Where are they used? So they may be used in some other function, in some other function, in some other function. Correct or not? Yes or no? Do you remember I told you for every function we have CFG? Okay, for every function in program we have CFG. Correct? Do you remember this? I told you for every function in program we have CFG, we have control flow graph. So for example, it's like this. Okay, it's like this. If you have a main function, okay, and in this main, let us assume you have something. Okay, for example, okay, I don't know, in this main maybe you are calling this f a comma b. Okay, and here you have something called int a comma b comma c comma d. Okay, something like this. Now you can notice that, okay, what I am saying that you will have control flow. So this is the control flow graph of main, this is the control flow graph of main, and this is the control flow graph of f. This is the CFG of function f. Now you can notice here there is something called entry, here there is something called entry, here there is something called exit, here there is something called entry. Okay, because we have entry and exit vertices, I told you. Okay, we have entry and exit nodes for in every CFG. So this is exit. Now, okay, now you can have something like this. Correct or not? Yes or no? Agree? So this is what I am saying. Maybe some variables might be live at the exit of control flow graph because they may be used in some other function. Okay, I hope this point is clear to everyone. Okay, so at the exit of control flow graph, at the exit, how is it possible? Okay, that some variables may be live because they may be used somewhere. Where they can be used? They can be used in some other function. So this is the point. Now let us take this example. So I am saying that this is given. I am saying that at the exit of this control flow graph, let us assume that x, y are live. Now tell me what are the live variables in each basic block. Okay, so tell me this point. So now what we need to do, this is control flow graph without loops. So what we need to do, all we have to do is just single backward iteration. Yes or no? What we have to do, tell me. All we have to do is single backward iteration. So this is okay. So single, because this is, so all we have to do is a single backward pass. I can say single backward pass. Okay, to find live variables, at each statement. Okay, so this is what you need to do. Okay, so what you will do, tell me what you will do. So here this is okay. So can anyone tell me what are the live variables at this statement? At this statement, what will be the live variables? At this statement, what will be the live variables? Okay, so at this statement, the live variables will be, you can apply the formula. Okay, so at this statement, what will be the live variables at this statement? Okay, so they will be what? X, C, D, correct? Yes or no? X, C, D. Because remember, I told you the formula you already remember. Okay, so what are the live variables at this statement? That will be simply, okay, so from x, y, you remove y, okay, you remove y, and you take union with AB. You take union with CD, correct? Yes or no? So this will be the live variables at this point. At this statement, what will be the live variables? Okay, at this statement, what will be the live variables at this statement? Okay, so tell me about this statement. What will be the live variables at this statement? The live variables at this statement. Okay, so they will be A, B, C, D. Yes or no? A, B, C, D, correct? Okay, so those will be A, B, C, D. Yes or no? Is this clear to everyone? Now tell me what will be the live variables here. What will be the live variables here? So what you will do from, okay, so okay, what will be the live variables here? What is the successor? This is the successor. For this statement, this is the only successor. This is the only successor. So here you have A, B, C, D. So here what we will have, you will remove A, so that will be B, C, D, and okay, so that will be, now what is live here? What will be live here? Tell me. So that again will be B, C, D. Okay, and what will be live here? What will be live here? Tell me. So that will be A, B, C, D. A, B, C, D. So that will be A, B, C, D. And what will be live here at this point? What will be live at this point? Okay, so here you can notice these are the two successors. So very important. Okay, remember these are the two successors. This and this. These are the two successors. Here you have B, C, D. Here you have B, C, D. Okay, so it means you are using B, C, D. Okay, and here you have A, B, C, D. It means you are using A, B, C, D. Okay, here you have B, C, D. Here you have A, B, C, D. So what you need to do? What you need to do? You need to take their union minus E. So that will be A, B, C, D. Okay, minus E. Okay, C, D. And what will be here? That will be A, C, D. So this is the point. I hope this point is clear to everyone. Okay, is this point clear to everyone? Anyone has any doubt in this liveness analysis? So when you don't have any loop, then this is how you can do single backward pass. Okay, so you can notice A, C, D, A, B, C, D. Okay, so this is your answer. If anyone has any doubt, you can ask. Okay. Anyone has any doubt? Okay. Sir, we are getting XY from some other block preceding this block in CFG. This I have already explained. Did you join late, Sai Kumar? I think you joined late, right? I have already explained. See, how can, from where these variables are coming? From where these variables are coming? These may be coming from other function. Okay, these may be returning, maybe they are returned from some other function. Yes or no? These may be used in some other function. So this I have already explained. At the exit, you can notice at the exit of control flow graph, how is it possible that some variables are live? How is it possible? They may be used somewhere. Okay, they may be used in some other function. For example, here they may be used some other function. Okay, so you have a control flow graph of main function, you have a control flow graph of function f, because for every function we have a control flow graph. So we have a control flow graph of main, we have a control flow graph of function f, and you can notice these variables a comma b, they may be used in this control flow graph of f. Okay, is this point clear? So you can notice these variables, they may be coming from some other function. Okay, so for single basic block in and generative set are equal. I will explain. This is coming. Okay, so let's see this now. Okay, if once you have done this, this is your liveness analysis. Remember, this is called liveness analysis. This is the result of liveness analysis. I can say this is the result of liveness analysis. Now, okay, tell me what are the dead variables? Which statements you can remove? This is my question. Which statements you can remove? So can anyone tell me which statements you can remove? So this is the result of liveness analysis. Now my question is, which statements are dead? Which assignments are dead? Which assignments, or you can say which statements? Which statements? Okay, which assignment or which statements are dead? Can anyone tell me? So you can notice which assignments are dead. You can notice. Okay, just think like this. Okay, is this dead? This is not dead because you are using y. You are using this y, so this is not dead. This is not dead. Why? Because you are using this y. So this is not dead. I can say this is not dead. This statement is not dead. Why? Because you are using this y. Okay, because of this. Because we are using this y. Because using y. Yes or no? So you can notice this is not dead. And this is also not dead because this is also we are using. So we are using this y. Correct? So this is also not dead. What else? What can I say? What is dead? Okay, so you can notice here BCD is dead. Okay, at this point BCD is dead. Means this statement I can, okay, means this x is unused. See what this tells. This says that these variables we are using. Okay, remember here BCD, these three variables we are, okay, what it means? Just tell me what they means. They mean that in future BCD are used, x is not used in future. Remember, in future BCD are used, x is not used. So because of this, I can say this is dead. I can say this statement is dead. Yes or no? This statement is dead. Similarly, these are the variables which are live here. Means this is also dead. Automatically means this is also dead. Okay. Yes or no? And similarly, this is also dead. Correct? Similarly, this is also dead. Okay. Do you agree? So you can notice, you can remove this statement, you can remove this statement, and you can remove this statement. Okay, so these statements you can remove. Finally, this is after removal of dead code. Okay, so this is after removing dead code. Removing dead code or dead statements. Okay, so this is the point. Anyone has any doubt? So far, anyone has any doubt? This is the question we have taken. Now, what to do when you have loops? Just tell me this point. What to do when you have loops? Okay, so when your control flow graph has loops, then what to do? If your control flow graph with loops, then what to do? Then, okay, so basically here what you will do? Here basically there will be many iterations. Okay, here will be many iterations of backward pass. Okay, so many backward pass you have to, multiple backward pass you have to make. Okay. So I can say that here I can say, okay, multiple backward pass we have to make. Multiple backward pass, okay, until nothing changes. Until nothing changes. So this I told you, this we have already seen. When you have loops, then all you have to do is just multiple iterations. Basically, multiple iterations. In this situation, all you have to do is just multiple iterations. Okay, so this is what you have to do, multiple iterations. So let's do this. This is your control flow graph without with loops. Okay, so what to do here? Again, so this is given to you. again this is given to you. Tell me from where this variable a is coming. At the exit of control flow graph. This is a control flow graph of some function. You have a function in your program. In your program you can have many functions. Okay, for one of the functions this is the control flow graph. Okay, and at the exit of this control flow graph we have this live variable. This variable is live. This variable a is live. Why this is live? Because it is used somewhere. Where it is used, it may be used in some other function, we don't know. Okay, so this is given that this variable is live at the exit of this control flow graph. Okay, now tell me, this is the loop. So you can notice in this there is a loop. Okay, so there is a loop, you can notice. Okay, so there is a loop in this function. In this control flow graph there is a loop. So what we need to do, we need to make multiple pass. Okay, so what the first pass? Initially this is the initial setup. So what you will do, initially everything is 5. Okay, I told you this is the initial setup. So initially this will happen, correct? Agree or not? So initially everything is 5. Okay, here this is given. Initially this is given. Okay, everything else is 5. Now what to do? Now tell me. Okay, backward. Go backward. Go backward. Okay, so first we will. Okay, remember always go backward. So first we will do this block. So tell me, when we do this block, then what we are going to get? Tell me what we will get here. Tell me what you will get here. Can anyone tell me what I am going to get here? So here I am going to get what? Okay, ABC I am going to get, yes or no? So here I am going to get ABC, correct? Okay, so here I am going to get ABC. Okay, is this point clear? So okay, so this is ABC I am going to get, because remember you can notice here. So this is the statement. Okay, so D equal to B plus C, and this is A equal to A plus B. Okay, and this is the live variable. Now what will happen here? So this is statement S1, this is statement S2. So what is this? Can anyone tell me what is this? This is out of S2, correct? This is out of S2. Okay, so what will be live of S2? Can anyone tell me what live of S2 means? In of S2. Yes, correct? In of S2. And what will be in of S2? What is the formula? You can apply the formula. Okay, so what is in of S2? In of S2 is simply, what is in of S2? That is out of S2 minus what are defined, what variables we are defining at S2. Okay, union what variables we are using at S2, correct? So finally what we are going to get? Tell me finally what we are going to get? So we are going to get, okay, so that will be ABC. Okay, so here this is, so you can notice this is in of S2. Okay, in of S2 is equal to ABC, and you can notice in of S2 is same as out of S1. This is same as out of S1. So what will be the, so tell me what is live at S1? Live at S1, what that will be? Live at S1. So what that will be? That will be out of S1. Okay, out of S1 minus what we are defining at S1. Okay, out of S1 minus what we are defining at S1, union what we are using at S1. Okay, so this is the point, correct? This is the point. Now what that will be? That will be, I can say ABC. Okay, so that will be ABC, and this ABC is same as in of S1. Okay, because in of S1 is same as live of S1. I hope this point is clear to everyone. Yes or no? So finally I can say that this is ABC. Okay, ABC. Now tell me, okay, so we are going backward, we are going in the backward direction. This is the first pass. Remember, we are making the first pass. This is the initial situation, and then now we are making the first pass. Okay, so we are starting the first pass. So okay, right now only first pass is going on. Remember, first pass is going on. Okay, so here right now first pass is going on. Okay, so what will be live here? Can anyone tell me? In the first pass, what will be live here? At this point, what will be live? At this point, you can notice ABC. Okay, so from this ABC, what you can do? So this A is not live anymore. Okay, so finally here what will be live? Here B comma C will be live. Correct? Yes or no? Agree? So here B comma C will be live, and what will be live here? What will be live here? That will be A comma B. So here BC will be live. Here AB will be live. Go backward. Go in the backward direction. Okay, go in the backward direction. So always go in the backward direction. Okay, so you can notice here AB will be live, here BC will be live. Okay, what else? So you can notice this is BC. Now okay, so what else? After this, what you can do? After this, what you can do? Tell me. So in the first pass, okay, so you can notice. Actually, always go in the backward direction. So we can take, if you go in the backward direction, then less things you will have to do. Okay, so tell me what will be live here. Now what will be live here? So you can notice these are the two successor, this successor, this successor. So you have two successor here. Okay, so you have two successor here, correct? Okay, so you can notice what you have. So now you have this successor, this successor. So finally, what will be live here? Here what will be live? Okay, so A, B, C, because this union this union this. Okay, so A, B, C, and then what you have here? So A, B, C, D, and then B will be removed. A, B, C, D. So this will be, okay, so B will be removed. So this will be A, C, D. Agree? So this will be A, C, D. If you go in the backward direction. Yes or no? Now this is your first pass. So the first pass is done. Now we will start the second pass. So you can notice the first pass is done. So now do the second pass. Okay. In the second pass, again go backward. Now again go backward. So this is the first pass is done. Now again go backward. So what you will do? If you go backward, then no change here. Okay, so here what you can see, so there is, this is also successor, remember. Now some things will change. What are the things that will change? Okay, so here what are the things will change? You can notice this is the successor. Okay, so you can notice this is also successor. So you have two successors here. Remember, you have two successors here. Okay, so what you will do? So you can notice what you will do. So you can notice this is ACD. So this ACD you will take. Okay, so finally, okay, so this is ACD because union is ACD. From ACD you will remove D. Okay, so then AC and then from AC, okay, then you will add. So this will be ABC. There is no problem here. Okay, you have two successor, so there will be ABC. This is no problem. There is no problem here. What else? Tell me what else? Okay, again go backward direction. So this will be ABC. In backward direction again you go. Here there will be no change because there is no change here. So there will be, so okay, one pass is enough. Can you notice second pass result is same as first pass result? So I can say one pass is enough. Yes or no? Correct? Second pass result is same as first pass result. So I can say first pass result is same as second pass result. So stop. So stop. So this is your final answer. Okay, so your final answer is, this is your final liveness analysis. Is this clear to everyone? Let me know. Okay, anyone has any doubt, let me know. So this is the final answer. You can notice one more thing here. One interesting thing I want to tell you. See, this is my suggestion that you should go backward. Always go backward direction. This is my suggestion. Okay, but okay, so this backward direction, because if you don't go in backward direction, then many iterations you will have to do. So remember, this is a note. If you don't go in backward direction, if you don't do backward direction, then many iterations you will have to make. Okay, if you don't go in strictly backward direction, in strictly backward, or I can say in backward direction, if you don't go in backward direction, then what will be the problem? Can anyone tell me? In the last lecture I told you, if you don't go in the backward direction, then more iterations you will have to do. Then more iterations you will have to do. There is no problem, but more iterations you will have to do. Okay, so this is the point. Now you can notice one more thing. Okay, what we did like this. Okay, so first we did this, then we did this, then we did this, then we did this. Correct? Yes or no? Yes or no? This is what we have done. Okay, but you can notice, if you do like this, just assume you do like this. If you do like this, so what? Okay, so what we did? So what we did in first pass. In first pass, what we did? Okay, what we did in first pass. So you have basic block B1, you have basic block B1, you have basic block B2, you have basic block B4, and you have basic block B3. Okay, so this is what you have. Something like this. So this is what you have. Now you can notice what we did in the first pass. So we first we did this. Okay, so this is what we did. So first we did this, then second we did this, then third we did this, and then fourth we did this. Correct? Yes or no? So first this we did, then this we did, then this we did, then this we did. Okay, so we have gone in the backward direction. Now just assume you don't do like this. Now just assume you don't do like this and you do like this. Just assume. Okay, now if you do like follows, like follow, okay, like following. If you do like following, for example, you do B4 first, then you do B2. Okay, so first you do B4, then you do B2, then you do B1, then you do B3. Okay, then you do B1, then you do B3. If you do like this in every pass, okay, if we do like this in every pass, okay, then we need 2 iterations. Okay, then actually we need 3 iterations. Then we need 3 iterations. Okay, and here we are using, okay, what we did. So we only need 2 iterations. Yes or no? Here we need 2 iterations. We needed 2 iterations. Correct? Agree? We needed 2 iterations. Only 2 iterations we needed. So we needed only 2 iterations. If you do like this, first you do B4, then you do B2, then you do B1, then you do B3. If you do like this, if you go like this, then you need how many iterations? 3 iterations you need. You can check it out. Okay, you can check it out. So if you go like this, then you will need these many. So if you do, so first we have done this. Now you are doing this. Now in the next iteration you are doing this. Okay, and in the next you are doing this. Now you can notice that again you go like this. Again you go like this, things will change. Okay, again you go like this. So what I am saying is 3 iterations you are going to need. Okay, so that is the reason always go in the backward direction. Is anyone has any doubt? Okay, anyone has any doubt? Anyone? So this is the point. Okay, so remember, so these are the points. I hope all these points are clear. So we have seen basic blocks, we have seen CFG with without loop, CFG with loop. Okay, all these things we have seen. I hope all these points are clear to everyone. Okay, so this is the idea. Can anyone tell me what are the dead statements? Find the dead statements. Okay, my question is find the dead statements. Find dead statements. So what are the dead statements? Find dead statements. So can anyone tell me what are the dead statements in this analysis? We have done the analysis. So what are the dead statements? So you can notice this is not dead. Why this is not dead? This is not dead because you are using this D. Okay, you are using, see, you are wait a second. Yeah, you are using this D. Can anyone tell me where we are using this D? See, this is not dead. Why? Because we are using, so because of this. Yes or no? This implies, okay, what this means? This means that we are using this D. You can notice you are using this D here. Can you notice this D you are using here? Notice. Where we are using this D? Can anyone tell me? Can anyone tell me where we are using this D? Where we are using this D? We are using this D, you can notice here. Okay, here we are using this D. So okay, you can directly see that this is not dead. This is not dead because we are using D. So what this actually means, this we are, it means in somewhere we are using D. Okay, somewhere we are using D. Somewhere we are using D. Correct? Okay, so this is not dead. What about this? Can anyone tell me? Again, this is also not dead because somewhere we are using A. You can notice we are using A on the exit. Okay, and what about this? This is also not dead because somewhere you are using C. You can notice here you are using C. Okay, and similarly, okay, this is dead. Can you notice this statement is dead? Yes or no? This statement is dead because you are not using D. ABC you are using, but you are not using D. So this statement is dead. What else? What else is dead? Okay, so only these are dead. So the only dead statement is this. So this statement, remember, this statement is dead. So you can remove this statement. This statement we can remove. Okay, so can be removed. Okay, clear? Clear to everyone? Okay, so let's see this is another question. Okay, and this is a very nice question. Okay, this type of questions you can notice GATE exam creates. Okay, in the GATE exam they create this type of question. What this question is saying: assume ABC are visible outside method. Can anyone tell me what this line means? Just anyone want to tell me what this line means? Anyone? What this line means? Assume ABC are available are visible outside this method. Anyone want to tell me what this line will mean? This line actually means the same thing I told you. It means that you are using this in some other function. Yes or no? It means you are using it outside the function. Somewhere you are using this. Okay. It simply means that these variables you are using in some other function, in some other control flow graph, in some other control flow graph of some other function you are using this. Okay. So that is the reason these variables are live at the exit. So I can say this is given to you. Okay. What is given to you? That variables a, b, c are live. This is given to you. Okay, so this thing is given to you, correct or not? Okay, so this is what I am saying. So this is given to you. Now what else? Assume x, y, z, t. These variables are not visible. It means these are not. These are not live here at the exit. These are not live. Okay, and the question is saying represent liveness using bit vector, and this is the order. This is the order. So you need to tell me what will be the bit vector here. This is my question. What will be the bit vector here? Means this bit vector you have to tell. What will be the bit vector here? This is the order A, B, C, X, Y, Z, T. Okay, bit vector. Bit vector means what this bit vector means. This simply means that 0 if live. Okay, 0 if dead. 0 if dead. 1 if live. 0 if dead. 1 if live. Okay, is this clear? Is this question clear to everyone? Anyone has any doubt in this question? Understanding the question is clear? Understanding the question is clear, right? Okay. So now tell me what is the bit vector here? Just tell me just tell me the bit vector. I am only interested in the bit vector. So tell me the bit vector here. So here what is the bit vector? So what is the bit vector here? Can anyone tell me? So here the bit vector is what? ABC are live. So here the bit vector is 1 1 1 0 0 0 0. This is the bit vector, correct? Yes or no? At the exit. This is given. This is given to you 1 1 1 0 0 0. And now what will be the bit vector? That will be 1 1 0. Okay, 1 1 0, because now C is dead. So 1 1 0, and what else? 0 1 0. Okay, 0 1 0 0, correct? Yes or no? Is it clear? Okay, so tell me what is the bit vector here? Okay, here what is the bit vector? Now this is the vector here. Okay, so it means 1 1 0 0 1 0 0. Okay, now here you can notice t comma z are live. Okay, so t comma z, they are definitely live. So t comma z are definitely live. And you can notice now B is dead. Okay, so this B is dead. And what about Y? What about Y? Y is already live, so this Y will be also live. So this Y is also live. Okay, and you can notice X is 0, and C is already 0, and this B is 0, and this is 1. So at this point 1 0 0 0 1 1. 1 0 0 0 1 1, correct? Yes or no? 1 0 0 0 1 1. Okay, now tell me what is, okay, tell me what is live here. What is the bit vector here? Tell me what is the bit vector here. Okay, at this point what is the bit vector? At this point what is the bit vector? That will be union of these two. Yes or no? That will be union of these two. So that will be 1 1 0. Okay, so that will be 1 1 0, and then you have 0 1 1 1. This will be the bit vector here, correct? Okay, now tell me what is the bit vector here. Tell me what is the bit vector here. Can anyone tell me? Here what is the bit vector? So here X will be dead. Okay, so here bit vector will be unchanged. That will be the bit vector. What is the bit vector here? Anyone? Now you can notice C is dead, X is alive. Okay, so now this C will be dead. So this will be 1 1 0. Okay, now this X is alive. 1 1 1 1. Okay, so this will be the bit vector here. And what is the bit vector here? At this point, what is the bit vector? So here the bit vector is basically t is gone. Okay, so this t you have to remove. Okay, so everything else is same. This t you have to remove. And what is the bit vector? Finally, what is the bit vector here? So here a is 0. Okay, because you are defining a, so that is gone. Okay, and you can notice y, x, y. Okay, so everything else is same. So 0 and then 1 0 1 1 1 0. So this is the final answer. 0 1 0 triple 1 0 0 1 0 triple 1 0 0 1 0 triple 1 0. Okay, is this clear? Is it clear to everyone? Tell me. Anyone has any doubt in this? This type of questions in the GATE exam they ask, yes or no, many times. Okay, this type of question they will ask. So they will give you this detail and they will ask you bit vector. So finally this bit vector you will get. Okay, so like this you can just check it out. Okay, I hope this is clear to everyone. If anyone has any doubt, you can ask. Okay, so this is the point. Now remember, as I told you, some authors, most of the authors, they use these things. Okay, as I told you. So remember, most authors they use this. So again, this use at statement. Okay, this mean this can also be said as generate. So use or generate, or you can say referenced, or you can say read, or you can say read. All these things are same. Okay, all these things are same. And also I told you define, that is same as kill, that is same as write. Okay, so these things are same. Now for each basic block find what. Okay, now for each basic block can you find? So far we have found, okay, for a basic block how to define this use and okay def. This is my, okay, so remember, for a basic block, for a basic block how to define. Okay, how to define use of a basic block. What is the use of a basic block and what is the define of a basic block? So this is my question, and this is very intuitive actually. Okay, the same way you have to. Okay, so this is also very intuitively you can define. Let me give you example and you can tell me. Okay, so just let me give you example. Consider this basic block. So let us consider this this basic block you consider. Okay, so for the statements we already know, but for basic blocks how to define these things. Okay, so if I give you, let me give you this basic block. Okay, so a plus b, and let us assume let's assume b equal to, okay, and b plus c, x is b plus d. Okay, so tell me, this is your basic block. Can anyone tell me how to, okay, just tell me this point, what should be use? Okay, this is your basic block, and for this basic block what should be use of this basic block? Means these are the set of variables used in this. Okay, set of variables used in b, set of variables used in this basic block. Okay, so can anyone tell me what should be? Okay, intuitively just tell me, what should be this, what should be these. So you can notice that first of all it means you start, okay, you are standing here, and what you are using, so you can see you are using b, correct? Yes or no? If you are standing here, from here can you see what you are using? So you are using b, you are using c. Are you using a? This is my question. Does a belong to this? Are you using a? This is my question. Are you using a? Tell me. Are you using a? This is assignment. Okay, so just take it as an assignment. Rajan, take it as an assignment. Okay, so don't confuse, this is assignment. You can just take it as an assignment. So tell me, This is my question. Can I say A is used in this basic block? And the answer is no. Okay, because remember, if you are standing here, just okay, from here, if you are standing here, then you can notice A is defined. A is defined before it is used. So here the answer is no. Okay, so A is not used in this basic block. Okay, so B is used, C is used, and you can notice A is not used. What about A, B, C? What about D? What about D comma X? What about D? D is used. Okay, so these are the used variables. Is it clear to everyone? Okay, similarly, tell me what are the defined variables? What variables you are defining? What variables you are defining in this basic block? So set of variables which are defined here. Okay, set of variables which are defined here. So defined variables are very simple. These are the variables. So A, B, X. Here you don't have to do any effort. Here actually you have to do effort. Set of variables used in B before any definition, before being defined. Yes or no? Okay, so remember, for any basic block, how can you write? Okay, so this is the point. Okay, for any basic block, if you have a basic, for any basic block B, what is use of B? Use of B is set of variables, okay, such that V is used in B, before defining B, before any definition of B. Okay, I can say before any definition of B, before any definition of variable V. Okay, so V is used before any definition of variable V. Correct? Yes or no? So V is used before any definition of variable V in B. So I am talking about only basic block. From basic block point of view, what is used? So the variables which are used, this is how you can define. Okay, and similarly you can define for any, if you have for any basic block, if you have a basic block, then how can you define? If you have a basic block B, for any basic block B, what can you say about def of B? Okay, remember, use of B, this is same as what are the variables generated by B, and this is same as what are the variables referenced by B, and similarly this is same as what are the variables killed by B, and these are the variables V is defined. Okay, V is defined in B. V is defined in B. Here you don't have to think about anything. Okay, just see what are the defined variables in B. Now just tell me, for each basic block, so let's assume this is basic block B1, this is basic block B2, this is basic block B3. Find what are the use and def set of variables for each basic block I am asking. So tell me what are the use of B1. Can anyone tell me what are the variables used in B1? Anyone? What are the variables which are used in B1? Rajan, here we, okay, notice that. Rajan, notice. See, here why this is not used. Okay, you can notice. See, why A is not used? Because just, okay, you are standing here. Just think about it. You are standing here. Now, you have A with you. Will you use it? Just tell me, Rajan, you are standing here. Before the basic block you are standing. Will you use A in this basic block? No, because we are defining. Because of this definition, I can say A is not used. Yes or no? Because of this definition, I can say the answer is no. Because of this definition. Yes or no? Is this clear, Rajan? So you can check this definition. So what is use of B? That is all those variables which are used before any definition, okay, in B. So what are the live variables in B1? Sorry, used variables in B1. So in B1, what are the variables we are using? We are using X, we are using Y. We are using X, Y. Okay. We are not using A, we are using X, Y. We are not using A. We are not using T. We are not using C. We are using X. Okay, X we have already known. We are using X. Nothing else we are using, correct? Yes or no? So these are the variables that you are using in this basic block. So for each basic block you have to find. Okay, so remember, note that A does not belong to use of B1, because in this basic block you are not using A, because when you are standing here you can notice in this basic block you are not using A because you are defining this A in the entry. Okay, so note that T also does not belong to use of B1. I hope this point is clear. So can anyone tell me what is the kill? Can anyone tell me what is the def of B1, or I can say what is kill of B1? This is the set of variables which are defined, that is ATCX. Okay, that is ATCX. So that is ATCX. Okay, ATCX. All these variables are defined, ATCX. Okay, now similarly tell me what is the used variables in B1, B2. In this basic block B2, what are the used variables? That is T, Z, correct? In this, so the answer is T, Z. Okay, and what are the defined variables in B2? That is B. This is the defined variable in B2. And what are the used variables in B3? And what are the defined variables in B3? So what are the used variables? Y. Okay, so this is the used variable and the defined variable is C. Okay, so like this you can define for each basic block you can find. Okay, is this clear? Okay, so let's see, this is your, again this is a CFG with loops, correct? This is a CFG with loops. My question is, okay, let's do the analysis of this. Okay, let us do the analysis of this. So tell me, backward analysis, always go in the backward direction. Okay, let's assume here nothing is, okay, so always go in the backward direction. So this is the first pass. So what you are going to do? Okay, do the basic, okay, again this is the question, do the liveness analysis. Do the liveness analysis. So what you will do, what you will get, tell me. This is a control flow graph with loops. So always go in the backward direction. So here initially nothing is there. So can anyone tell me what is, okay, can anyone tell me what is live here? Okay, at this point what is live? At this point, anyone? At this point what is live? So what is live is A, B, okay, and X. A, B, X, these are the live variables here. Always go in the backward direction. Now tell me what is live here. Remember, first pass is going on. Right now first pass is going on. So what is live here in the first pass? Okay, so this is ABX. Now AB, so here X will be removed, then A will be removed, so you have BXW. Now W will be removed, so this will be BX, correct? So this will be BX, correct or not? Okay, similarly you tell me what is live here, because remember the first pass is going on. Okay, so first pass is going on, so what is live here? So here what will be live? That is ABX. Remember this is ABX. From this ABX you remove W. Okay, and what you remove? So this will be, again this will be ABX. So again this will be what ABX. Okay, so this, and okay, what will be live here? That will be, remember this is a successor, this is a successor. So these are the two successor. Okay, so BX union ABX. This union this, ABX union BX, that is ABX. Okay, minus V and minus X. So X will also be removed. So this will be A, B. Yes or no? This is the first pass. So what we have done? We have only done the first pass. So far we have done first pass. Okay. Now let's do the second pass. Now let's see, will anything change in the second pass? Because there is a loop. Okay. So let's see, will anything change? Okay. So this will not change. There is no problem here. This will not change. So what we are going to change? Okay. This will not change. Okay, what else will change? So you can notice here, for this, what are the two successor you have? So remember, this is a successor, this is a successor. So remember, these are the two successor. Yes or no? Remember, these are the two successor. So what you are going to do? So this ABX union this ABX union this ABX. So that will be ABX. Okay, so here finally what you have? So because these are the two successors, so this you will get ABX. Okay, actually it will not change anything, but I just want to tell you that these are the two successor. Okay, so this ABX, and you can notice the next successor is this. Okay, so here what you have, here you have ABX, and here you have ABX. Okay, so finally again this will be ABX minus W, and okay, so that will be ABX. So here also nothing will change, here also nothing will change. So again second pass is same as first pass. So you can notice that second pass result is the same as first pass result. So stop. So this is your final answer. Can anyone tell me which statement is dead? Anyone? Okay, so which statement is dead? Can anyone tell me? So you can notice that first of all this statement is dead. Okay, so these are the dead statements. So you can notice this is a dead statement. You can remove this statement. Okay, similarly this is a dead statement. You can remove this statement also, because this is also a dead statement. Correct? Okay, so this is a dead statement. This is a dead statement. And what about, okay, so this is not a dead statement, and you can notice that so this is also dead statement. So these statements you can remove. Similarly this is also dead statement. Okay, so you can very easily, you can notice that these statements are sorry, this statement is not dead. See, remember, this statement is not dead. This statement is not dead. Why this statement is not dead? Can anyone tell me? Because what is live here? What is live here? Here what is live? So you can notice this is ABX, okay, minus V, so that is ABX. That is BXW, correct? This is BXW. Okay, so this is not dead. Remember, this statement is not dead, correct? Okay, so this statement is dead, this statement is dead, this statement is dead. So, okay, and similarly you can notice this statement is also dead, this statement is also dead. So like this, actually from the first pass many statements are getting dead. Okay, so this statement is also dead. So these statements you are getting dead. Then you again do the iteration, then many statements will be dead again. Okay, if you do the iteration, again many statements will be dead. So after the first pass, many statements are dead. Okay. Okay, so anyway, okay, just forget about it. Let me give you a note. I told you in the last class also. Do you remember? Do you remember that this I told you that if you do liveness analysis, okay, so first you do liveness analysis. Okay, first you do this, then if you do this dead code elimination, then if you do this dead code elimination, can anyone tell me what this will, then what will happen? If you do like this, then what will happen? Some dead code will be removed. If you do this, then some dead codes will be removed, not all. If you do this, then some dead codes will be removed, not all. So what we will have to do? So we have to do again. Okay, so we have to do again, we have to repeat what we have to. So we have to repeat this. What we have to repeat? First you do liveness analysis, okay, and then you dead code elimination. So you have to repeat this. So you have to repeat this until nothing changes, until no statement is removed. Correct or not? Do you agree? In the last class I told you, if you do like this, first you do analysis, then you do elimination. If you do like this, then some dead codes will be removed. Okay, remember, this is very important. Some dead codes will be removed, not all. If you want to remove all the dead codes, then you have to repeat. Okay, so we have to repeat this process. Again do the analysis, again eliminate. Again analysis, again eliminate. So what is the best way? Can anyone tell me what is the best way for dead code elimination? For dead code elimination, what is the best way? Okay, combined algorithm, yes or no? The best way is combined algorithm. I told you in the last class also, I told you the best way is combined algorithm. Means this liveness analysis, okay, this liveness analysis plus dead code elimination, you do them together. You do them together after, okay, together, you do them together. Correct or not? This I told you in the last class. So take care, okay, do them simultaneously. Okay, so this we have already seen. This is your GATE exam question. This we have already solved in the last class. Okay, if anyone has any doubt in this question, you can ask. But let me tell you, in the last class we have already done this. But in the last class when we were solving this question, okay, we took more time. Okay, what we were doing, do you remember? In the last class we have already done this question. Okay, so at that time, after every statement we were finding, yes or no? Yes or no? After every statement we were finding, before and after every statement we were finding, correct? We were finding here. Sorry, this is what we were finding. We were finding at this statement, at this statement, at this. So these we were doing, yes or no? So this is what we were doing in the last class. Do you remember? Okay. So now you can notice here that, can anyone tell me, can I save some time? Okay, here for every statement I have to do. Okay, in the last class we have done this question we have done, and for every statement we have done. Okay, like for this statement we found, then for this statement we found, for this statement we found, for every statement we were doing the analysis. Okay, for every statement we were finding, for every statement we found, for every statement we found set of live variables. Can we do something better? Tell me, this is my question. Can we do something better? For every statement we found, can we do something better? Like for every statement we were finding, now my question is, can we do something better? Anyone want to answer this? Do you remember this question we have already solved? Do you remember, for every statement we found the set of live variables. Now what we can do better? The better thing we can do is just find for basic blocks. Don't find for each statement, just find for basic blocks. Because in this question, he is asking what is live at basic block 2, basic block 3. So what better we can do? So something better we can do. Okay, so for each basic block you find, for each basic block you find, what you find? For each basic block you find what is the def B, what is the use B, okay, and what is in of B and what is out of B. So for instead of each statement, so instead of each statement, so remember, don't do okay for each statement. Instead of each statement, what you do? Instead of each statement, for each basic block you do. So this is what we are going to do now. Okay, this same question we will solve, okay, but with a different method. Now the different method we are going to apply. So what we are going to do, for each basic block we will do. So this is your basic block B1. Let's call it B1. Let's call it B1. For basic block B1, can anyone tell me what is use of B1? What are the variables we are using at B1? And what are the variables we are defining at B1? Tell me, what are the variables we are using at B1? The variables Q, R. So we are using Q, we are using R. We are not using P, we are not using S, we are using QR, okay, V. We are using QRV, correct? We are not using S, we are not using P, we are using QRV. Nothing else we are using, yes or no, correct? So this is the use of B1. These are the variables which are used in B1. And what are the variables defined in B1? PSU. Okay, so these are the variables defined in B1. PSU. Okay. And similarly, now here you don't have, okay, because this is only single statement, this is only single statement, this is only single statement. Okay, so you don't have to worry too much. But like this, you can save some time. Now you can save some time. Okay, now what? Okay, now tell me what is the live variables. Again, the same thing will happen now. Now also there is something called, the same formula will work. Remember, the same formula will work for basic block. Okay, same formulas work for basic block. Same formulas for basic blocks. So if you have, okay, if B is a basic block, then what you need to do? The same formula will work. So what is the in of B? In of B will be out of B minus what you are defining in B union what you are using in B. Okay, and similarly, what is out of B? out of B is union of all the successors, union of in of all the successors. Okay, so this is the same formula is going to work for each basic block. For each basic block you can basically, and again the same thing will happen, that live of a basic block, live of a basic block is same as in of basic block. Okay, so similar, okay, so basically live of basic block, that is nothing but in of basic block, and that is nothing but, you already know, out of basic block minus what you are defining in the basic block union what you are using in the basic block. This will save you some time. Okay, so this method, this is going to save you a lot of time, this will save you. Okay, so now the same question you can solve using this method. Okay, so let's solve the same question. Now let's solve, so this question we will solve it. So tell me now, okay, can you try this question now? Okay, so what will happen here? So let's see what will happen in the first pass. Okay, so here again go in the backward direction. So in the backward direction if you go, then what will happen? Let me just remove everything else. Let me remove, just wait. Okay, so now you can solve this question again. So now what will happen? Again the same thing will happen. So okay, initially what will happen? Everything is phi. Okay, for everything you can say everything is phi. This is also phi, this is also phi. Okay, everything is phi, this is also phi, everything is phi. Okay, so initially everything is phi, you already know. Okay, so let's do the first pass. Let's do the first pass. Then what will happen? Tell me. If you do the first pass, then what is this? What is live at this statement after the first pass? What is live at this statement? So this will be V comma R, correct? So these are the live. Okay, I am doing the first pass. Now tell me what is live here? What is live here? That will be, V will be removed. So that will be RU. Okay, and what will be live here? Can anyone tell me? Just go in the backward direction. Very simple. Okay, just go in the backward direction. So from VR you remove V, and okay, U will be there. Now similarly here VRSU. Okay, so this will be here. And what is, okay, what will be here? So what is here? So can anyone tell me what is here? Can anyone tell me what is here at this point? Can anyone tell me? This will be union of this and this, because these are the two successors. This is a successor, this is a successor. So this will be what? So this will be VRSU. Okay, now tell me what is this? Okay, now you can notice you don't have to do for each statement. This is the benefit. The benefit is you don't have to do for each statement. No need to do for each statement. This is the benefit. No need to do for each statement. Don't do. Okay, directly you can do. Okay, so what will be the in of B1? What will be in of B1? Okay, for this block B1, what will be in? That will be what? That will be out of B1. Okay, that will be, this is out of B1. So that will be VRSU minus what you are defining, PSU. Okay, what you are defining, PSU. Union, what you are using, I told you here. Okay, QRV. You are using QRV. So after the first pass, what is the result you got? Can anyone tell me? So finally what you got in of this will be VRSU. Okay, from this you will remove, basically SU will be gone. So VR. Okay, so this will be QRV, correct? Agree or not? So this is your first pass. So after the first pass, this is the benefit. Is this clear? This is the benefit after the first pass. Can you notice a lot of things you don't have to do for each statement? This will save you some time. Did you see it is saving some time? You don't have to check for each statement. You just have to do for the block. Okay, so now this is your QRV. Now this is your first pass. Now again what you do? Now again you do the second pass. Okay, so now what I am going to do is second pass. So for this question, let's do the second pass. Okay, so this will this change? Now you can notice this is a successor, this is a successor. Okay, and for this is QRV. Okay, so this is QRV. So finally this will actually not change because you have QRV. In the second pass this will not change. Why? In the second pass this will not change. Why? Because what will happen here? In the second pass this will happen that from QRV you will remove Q. Okay, you will remove Q and then you will union with VR. Okay, so that is same as VR. So this will not change. Okay, so you can see there is no change. You can notice there is no change. Yes or no? But this you should take care that this is a successor. Okay, this you should take care. Remember, this is a successor. So many students they basically don't focus on this. This is a successor. This is a successor. So you have to, from this you have to remove that. Okay, from this is your out of 4. Remember, this is your out of block 4 and this is your def of block 4 and this is your use of block 4. Okay, so remember, so now there is no change here. Now there will be no change here, there will be no change here. Actually there will be no change anywhere. Okay, so first pass result is same as second pass result. So finally what you can say? So you can say here that first pass result same as second pass result. So you can stop. So this is how you can do. Okay, I think I wrote in the unseen area. So let's see this. Okay, so you can just check it out. I am just showing you what I have written. Okay, so can you see? Can you see this? So these are the slides. Okay, so this is how you can do. Now remember, this will save you a lot of time. This will save you. Okay, if you have this type of thing. Okay, so remember, okay, go blockwise. Okay, going blockwise, remember, so this is the point. Okay, going blockwise can save you time, okay, instead of statement wise. Okay, instead of statement wise. So going blockwise, that will save you time. Okay, because if you have this type of scenario, let us assume here you have many statements, statement, here you have statement, here you have statement, and here you have statement as well. Then in this type of scenario you can notice a lot of time you will save. Okay, a lot of time you will save. Going blockwise will be, okay, so remember, in this type of scenario, going statement wise is stupidity. Going statement wise is stupidity. Yes or no? Yes or no? Do you agree? Going statement wise is stupidity here. Okay, so go blockwise. Here you can notice, here you should go blockwise. For each block you find what are the defined, what are the used, and like this. Okay, so anyway, so like this you can do. Okay, this is a very nice table if you want to understand what this liveness analysis actually means. So this is the very nice table you can check. Okay, what this situation means, can anyone tell me? Like V is neither used nor defined. What this situation means, can anyone tell me? V is not used, not defined. For example, here V is not used, not defined, correct? This variable V is not used, not defined. Then what it means? It means that liveness is not affected by this block. This block is not affecting the liveness, correct or not? Now similarly, here V is used but it is not defined. Then what it means? It means before the basic block, this V will be live. Yes or no? So actually you can notice, for example, the first statement. Okay, you have a basic block. In this basic block you can notice that neither you are defining V, okay, nor you are, okay, nothing you are doing basically. It's like this. Okay, so B equal to C cross D. Now you can notice that this is your basic block. Okay, there is something here, so I can call it in of B, and I can call it out of B. You can notice that because of this basic block, okay, because of this basic block, okay, because this liveness of variable v is not affected. Yes or no? Correct. This will not affect the liveness of v. Yes or no? Because there is no v here, so you don't have to worry. Now similarly, if you are generating v but you are not killing v, if you are generating v but you are not killing v, then what will happen? For example, you can notice you are using C. Okay, what that means. So okay, the second scenario. What is the second scenario? The second scenario is like this. You can very easily see that. What about liveness of C? Just tell me, liveness of variable C. What can you say about this? Liveness of variable C. You can notice that C is used, but C is not defined. In this basic block, I can say C used, not C not defined. Then what it means? Then I can say that before the basic block C is live. Then what it means? It means I can say that before this basic block, I can say before B C is live. Yes or no? I can say before B C is live. And what is the third scenario? If you are not generating but you are killing, means you are defining but you are not using. The third scenario. In the third scenario, I can say this is your basic block. You are defining but you are not using. Okay, consider this scenario. A equal to B plus C, and let us assume you have C equal to B into D. Now you can notice here, focus on this variable. Okay, so this is defined but not used. Then what it means? Okay, what it means? Then it means what? So what can you say about liveness of A? Liveness of A. What can you say? What can you say about liveness of A? So if this is the scenario, then what can we say about liveness of A? Then we can say that before B, then we can say that before this basic block B, A is not live. Correct? So this is the table you can check. Okay, this table is very nice if you want to understand the liveness analysis. And both defined and killed. In this situation, what will happen? Both defined and killed. Okay, so it is defined also and it is killed also. It means, okay, it means liveness is killed, but it becomes live before the basic block. It's like this. In this scenario, what will happen? The fourth scenario, you consider this scenario. A equal to, okay, B plus C and B equal to A plus D. In this scenario, focus on B. You can notice variable B in this basic block. You can notice that variable B is defined and used, is defined comma used. So you are using also, you are defining also. You can notice, okay, you are using also and you are defining also. Okay, then in that case, what can you say? Then in that case, if this situation happens, then in that case, what can you say? You can say that B is live before B. B is live before basic block B. Correct? Yes or no? This scenario, okay, tell me, this comes under which scenario? So the first scenario, second scenario, third scenario, fourth scenario. We have seen all the scenario. You tell me this will come under which scenario? Okay, this is what I want to ask. Okay, just tell me this will come under which scenario? Okay, for variable A, which scenario is applicable? For variable A, which scenario is applicable? Tell me. We have seen 4 scenario. For variable A, which scenario applicable? This is my question. We have seen 4 scenario. For variable A, which scenario is applicable? Only for variable A I am asking. Which scenario is applicable for variable A? Which scenario? Scenario A, scenario B, scenario C, scenario D. 1 to 4. 1 to 3, 4. For, okay, these are the 4 scenario. For variable A, which scenario is applicable? Okay, for which scenario is applicable? Okay, I am giving you 4 options. I am giving you 4 options. You tell me which scenario is applicable. The first scenario is that A belongs to use of B. Okay, A belongs to use of B. A does not belong, A also belongs to def of B. A does not belong to use of B. A belongs to def of B. Which scenario is applicable? Tell me. Again, A belongs to use of B, but A does not belong to def of B. A does not belong to use of B. A does not belong to def of B. This is my question. Which scenario is applicable? Anyone? Anyone? You can notice that A is definitely defined, right? A is defined, but A is not used. So answer is option B. A is defined. A is defined, but A is not used. Yes or no? Yes or no? Because you can notice for this basic block, what are the used? What are the used variables? The used variables are B, C, B, C, D. And what are the defined variables? For this, the defined variables are A, B. Yes or no? Is it clear to everyone? See, for a basic block, I told you. What do you mean? For a basic, in this basic block, A is not used. In this basic block, A is not used. In this basic block. Don't make this mistake. Many students are making this mistake. In this basic block, A is not used. Is this clear point? Is this point clear to everyone? So don't make this mistake. Okay. What can you say about for variable B? So okay, I hope this point is clear to everyone. That is the reason I have taken this question. Okay. Is this clear? So you can take, for example, you can take this question also. A equal to A plus B. B equal to B plus C. C equal to C plus D. Tell me what is used. What are the variables which are used in B? Tell me. And what are the variables which are defined in B? Tell me these points. What are the variables which are used in B and what are the variables which are defined in B? So used in this B, in this, what are the variables which are used? So you can notice B is used, you can notice C is used, and you can notice D is used. Again you can notice this is used, this is used, and this is used. And what are the variables defined? A, B, C are defined. So these are used and these are defined. Yes or no? Now is it clear? Okay. So note that for a basic block, for any point n. Now this point can be basic block or a statement. This point can be basic block or statement or age. Okay, this point can be anything. For a point, okay, for a point, this can be a basic block or this can be statement or this can be age. For any point, remember that def of n, use of n, use of n may not be disjoint, need not be disjoint. Okay, may not be disjoint. Okay, and you can note here that in this, remember, in this note, A is not used. A is not used in basic block B. Okay. A is not used. Sorry. Okay. Sorry. A is actually used. Yes. Okay. Here A is used. Okay. Sorry for that. A is actually used because here A is used. You can notice A is used. Okay. So sorry for. Okay. Very good. Okay. See, that is like, this is called learning. So now you are telling me what is the mistake. Okay. Now you are telling me what is the mistake. So that is a very good thing. Okay. So note that A is used. Okay. So A is definitely used in this basic block. So you can notice A, B, C, D. These are the used variables. Okay. So like this. Here you can notice here A is not used. Okay. So in this you can notice that A is not used. Okay. So like this you can do. Is it possible that use and def can be same? Is this possible? This is also possible. You can notice if you have a statement like this, a is equal to a plus a, okay, or you can say a is equal to 2 plus a. In this is okay, for this statement n, you can notice what is use of n. Use of n is a, and what is def of n? What is def of n? What is def of n? That is also a. So they can be same also. So you can notice they can be same also. Okay. Anyway, so like this, can you do? So these questions I can give as a homework. So this is your program. Okay. For this program, you need to find, okay, what is this set of variables for each basic block. For each basic block you find. So can anyone tell me what is the answer for B1? Okay. So let me make a table, and can you tell me for each block? Okay, so just tell me the answer. Okay, let me make this table, and you tell me, here I am writing the block, here I am writing the used, okay, and here I am writing the block B, and here I am writing what are the variables defined in B. So tell me, for block B1, what can you say? For block B2, what can you say? B3, what can you say? Okay, B4, what can you say? And B5, B6. Okay, so tell me, for these, what can you say? Okay, so for B1, what you are using in B1? In B1, you're not using anything. So that is phi, correct? So that is simply phi, nothing. You are not using anything. Okay. And what you are defining A, B, C, M. These you are defining. In B6, you are not using anything. You are not defining anything. There is no variable. You are not using anything, not defining anything. B2, in B2, you are using A, comma, M. You are not defining anything. Okay. In B3, you are using A, you are defining A. Okay. In B4, you are using A, but you are not defining anything. Okay. You are not defining anything. And in B5, you are using A, you are using B, you are using, okay, and C you are using, okay. So this is, and what you are defining T1 comma A. This you are defining. Is this clear? Okay. This table is clear, right? So like this you can do, okay. So now you can do the liveness analysis also here if you want to do. For this question, you can do the liveness analysis, okay. First iteration, second iteration, like this, okay. So tell me what will be the result after first iteration. For this question, what will be the result after first iteration? Now you do liveness analysis. Now, okay, do the liveness analysis. So just tell me what will be the, okay, just go in the backward direction. So if you go in the backward direction, here everything will be phi, correct? Okay, so you can very easily notice that here this will be phi. Okay, so what about this basic block? Okay, so this is also phi. Okay, so this is your first pass, I can say. So now right now we are doing the first pass. So you can notice this is the first pass. In the first pass you can notice this is phi, this is phi, this is phi. And what about this? So this basic block 5, this is using ABC and defining TA. Okay, ABC you are using ABC and you are defining TA. Okay, T1A you are defining. So this will be ABC. Okay, just go in the backward direction. What about this? Here you are using again ABC. Here also you will get ABC. Just go in the backward direction. I am going in the backward direction. Okay. Okay. So what will be this? What will be this one? So this one will be what? So you can notice, or I can say first you find what is this. So this will be what? This will be A. Correct? This will be what? This will be A. Now you find this. Okay. So this is A. This is ABC. These are the two successors. This and this. These are the two successors. Okay, for this statement. So I can say that is ABCM. ABCM. So this is your, okay. And then finally, what is this? This will be, okay. So here what will happen? Here you can notice from this ABCM, you will remove ABCM. Okay. And then, okay. So this will be phi. This is your first pass result. This is the result of first pass. Okay, so this is the first pass. Now let's see what is the second pass. Now let's do the second pass. So first pass is done. Now let's do the second pass. In the second pass, what can change? Let us see. So again here this is 5. Again here this is 5. Okay, so there is nothing to change here. Can it change this ABC? This ABC also will not change. Okay, and what can change here? So nothing. Okay, so far there is no change. And what can change here? For this 3, what can change? Okay, so for this 3, this is the successor. This is the successor. So for this 3, this will be ABCM. For this 3, this will become ABCM. So this change will happen. Yes or no? This will become ABCM. This change will happen. And now, okay, after this change is happening, now you can notice for okay, so this change you can notice. So this ABCM will become ABCM, and finally, okay, so this is ABCM. So again, this will become ABCM, and then this is also 5. Okay, so this is your answer. So this is your second pass. After the second pass, nothing will change. So you can notice the third pass also will be same. If you do, the third pass will be same as the second pass. You can check. The third pass is same as second pass. So finally I can say that second pass and third pass are same. So I can say stop. So you can notice second pass result is same as third pass result. So stop. So this is a very big note I want to tell you. This is a very big note. Take care of successors. In each iteration, take good care of successors. Okay, so don't forget the successors. This is where most mistakes will happen. Many people will forget about successors. For example, here for this statement, what are the successors? The only successor is this. This is the successor. So for this statement, for this basic block 3, the successor is basic block 2. Okay, so don't forget the basic, the successors you don't forget. This is the whole point. Okay, I hope all these points are clear to everyone. Okay, so this is your answer. You can check like this. Okay, so I can give some questions as a homework. I hope liveness analysis is clear to everyone. Okay, can anyone tell me what do you feel about liveness analysis? Are you confident? Like any question they give you, whatever question they give you, can you handle? Everything we have covered. There is nothing we left out. Okay, every single thing we have checked. Okay, every variation, anything that comes to my mind, I've done it. Okay, so this is the, okay, this is another question you can notice. For this, how can you make control flow graph? So you can just check it out. Okay, I am not going to explain, but you can check it out. For this program, you can very easily write the control flow graph. Okay, so how to write the control flow graph? Very simple. You can notice I equal to m minus 1. So this is I equal to m minus 1. Okay, then this condition will be checked. Okay, so this condition will be checked, and then if this condition is true, then you will go here. If this condition is false, then you will directly go out of this for loop. So you can notice this condition. If this condition is true, you can very easily notice. If this condition is true, you will go here. If this condition is false, you will go here. Okay, and similarly, what you can do after this, what you can do, if this is true, then you will check this. If this condition is true, you will go here. If this condition is false, you will go here, and then this I plus plus will happen. This I plus plus will happen. Okay, so for this program, you can write the control flow graph like this. Okay, is this clear? See, very simple. In the GATE exam, they will not ask you. In the GATE exam, they are not going to ask you to convert this into control flow graph. This is just for our understanding. Okay, so this program you can very easily convert into control flow graph very easily. Okay, in the GATE exam, they will not ask you. Now, once you have this control flow graph, they can ask you liveness analysis. Okay, so I am giving this as a homework. You can check it out. So for this program, for this control flow graph, can you do liveness analysis? Okay, so this will be the answer. Okay, so the answer is this. Okay, so do the liveness analysis. Basically, do the liveness analysis. Okay, and this is the answer. You can just check it out. Okay, first iteration, second iteration. So always go in the upward direction. Okay, just go in the backward direction and you can do it. Okay, now without doing the liveness analysis, I want to ask some questions. No, Nagesh, in the GATE exam, they will not ask you to convert any program into control flow graph. In the GATE exam is objective, that is not subjective exam. Okay, this is just for your confidence or for your practice. This is a very simple thing. Okay, you just check it out, very simple. Okay, this is your program. For this program, you can very easily check it out that this control flow graph you can create. Can you understand that for this program you will get this control flow graph? Okay, all you have to do, just understand this. You don't have to create. Don't create. Just understand that these are same. That these are same. These two are same. Okay. So without doing the liveness analysis, can anyone tell me? Can anyone tell me? Can anyone answer these questions? Without doing the liveness analysis, can you answer these questions? Where to practice liveness analysis? Go classes. So many questions we are taking. You are not going to find these many questions anywhere. Nagesh, you can check any standard resources. You will never find these many variations, these many questions, these many variety. Okay, anywhere. I am already taking all the variety of questions. Okay, so you don't have to go anywhere. If you are confident in the Go classes lectures of liveness analysis, then you do not have to do anything. No practice. No need of doing any practice. I am already doing all the practice you need. Okay, just tell me. Okay, without doing the liveness analysis, can anyone answer these questions? Let's see. The first question: is this variable a live at exit of node 5? Can I say here variable a is live? Don't do liveness analysis. Without doing liveness analysis, can anyone tell me? Can anyone tell me how to? What is the answer? At this point, okay, at this point is a live? This is the first question. At this point, can you say at this point a is live or not? At this point. At this point a is live or not? It means that at this point, are you using a? Is there any chance you are using a? Is there any chance? Is there any chance you are going to use a in future? At this point, a is live or not? A live or not? A live or not? Tell me at this point. Is there any chance in future you are going to use a? Is there any chance? Of course there is. Of course there is a chance. Can you notice? Can you notice this? You can go here, you can go here, you can go here, you can go here, and you can go here, and you can go here. Yes or no? This path you can take. So the answer is yes. Answer is yes. Because you can use. Okay, because what you can do, from block 5 you can go to block 2. From block 2 you can go to block 3. From block 3 you can go to block 5. And in this block 5 you are using a. In this block 5 we are using this variable a. Yes or no? Is this clear? Okay, so without doing liveness analysis, can you answer these questions? So these questions you have to answer without doing liveness analysis. Without liveness analysis. Okay, don't do liveness analysis. So I can say without. Basically, apply the concepts, apply the definitions, apply the ideas. Without doing liveness analysis, can you answer these questions? So you can notice that. Okay, so the answer is here, yes, because you can use. Okay, now the second question. What about the second question? Can you answer the second question? Okay, this second question. Is a live at the exit of node 5? Okay, so anyway, okay, don't worry about this iteration. Okay, don't worry about the iteration. Don't worry about, okay, sorry for that. Don't worry about the iterations. Don't worry about the iterations. Okay, so let me just correct it. Don't worry about the iteration, because no one is going to ask you first iteration, second iteration. In the GATE exam, they will not ask you first iteration, second iteration. That is stupidity. They will not ask you first iteration, second iteration. Okay, so tell me now. So don't worry about the iteration and all. Okay, so tell me this question. Don't worry about iteration, Rajan. In the GATE exam, they will not ask you iteration 1, iteration 2, iteration 3. These type of things they will not ask you, because how many iterations it will take, that depends on the algorithm you are applying. I told you, okay, in which sequence you are doing, whether you are going backwards or whether you are going forward, backward, that depends on that. Okay, so iteration depends on how you are doing the analysis. Okay, so do not worry about it. Don't worry. So just tell me what is the answer here. Is A live at exit of node 5? Okay, so let me ask you, let me change this question and let me ask you exit of node, okay, exit of node 3. Exit of node 3. So tell me what is the answer. Exit of node 3 means here. Okay, here at this point is A live. At this point, this is my question. At this point is A live. Is A live at this point? And the answer is again yes, because what you can do, from block 3 you can go to block 5. In this block 5 you are using A. Okay, and what about the next question? Tell me what about the next question? Show execution along which, okay, A is live at the, okay, so this we have already done, right? This we have already done. Exit, okay, this we have already done. And show an execution path along which this is not live at exit of node. Okay, this is not live. Show an execution path. So you can very easily show, okay, that from B3 you can go to B4. You can go to B4. Okay, so you can go to B4. If you do like this, you go to B4, then you go to B5, and then you go to what? B2, and then you go to B6. Okay, so anyway, any type of question they can ask you, you can handle. Okay, without doing liveness analysis, can you answer these questions quickly? Quickly tell me, why is Z live at X? Okay, so is Z live? Just tell me, is Z live? This is the first question I want to ask. Is Z live? Tell me the answer. Is Z live? These are the questions. The second question, the third question. So tell me what is the answer for the first question. For the first question, what is the answer? Is Z live at the exit of node 5? Means here at the exit of node 5, here at this point is A live? This is the question, correct? Is A live here? I am talking about the first question. Okay, in the first question I am talking about. So here is A live. Tell me, are you using this A anywhere? Okay, are you using this A anywhere? Is there any place where you are, okay, variable Z is variable Z. Are you using this variable Z anywhere? Okay, so you can notice, yes, we are using, correct? Because what you can do, answer is yes. Answer is yes. Why? Because what you can do, you can go from B5, okay, from N5, you can go from N5. From N5, what you can do, you can go to N3, and in this N3 you are using Z. Yes or no? This N3 is using Z. Okay, tell me the next question. Tell me the next question. Is Z, okay, yeah, so anyway, okay, is Z live at entry? Is Z live at entry? Tell me the answer for this question. Is Z live at entry of N5? So what is the answer? At entry of here, at this point is Z live? Is Z live? And the answer is no. Why? Because you are not using. If you are standing here, then we are not using, correct or not? So the answer is no, because you can very easily notice that in N5 Z is dead. Okay, in N5 you are, okay, basically Z is dead. Z is defined, correct? And what about question number 3? What about question number 3? Is X live at exit of N3? Is X live at exit of N3? Here at this point, is X live? Is X live? This is the question. Tell me, is X live here? What is the answer? At this point is X live. So what you can do, you can Yes, answer is yes. Why? Tell me why. Because from n3 what you can do, you can go to n5, and from n5 you can go to n6, and in this n6 you are using x. This n6 is using x, correct? This n6 is using x. Okay, so like this you can do. I hope this is clear. Okay, so everything, every single variation, everything we have seen. Okay, so do liveness analysis. These are for your practice. Anyone, some like, okay, some students are asking for practice. This is for your practice. Take it as a homework. For this, do the liveness analysis. The answer is this. This is the answer. You can check it out. Okay. Okay. So for this question, the answer is this. So that's it. Okay. So everything we have seen. So this you can notice. X, Z. Tell me for this basic block. For this basic block, x equal to x, okay, and x equal to x plus 1. For this basic block, can anyone tell me what is the use? Just quickly tell me what is the use of B and what is the defined in B. What are the variables you are using in B and what are the variables you are defining in B? Quickly tell me. So the answer is very simple. What are the variables you are using in B? You are using Z. Okay, the only variable that you are using in Z. Okay, and what you are defining? Only X. Okay, so you are using Z. Okay, so remember X is not used in B. X is not used in B. Okay, so this is the idea. Another question is X equal to Z. Okay, and another question is Y equal to 1. Another question, if I put Y equal to 1, now what is the answer? Now the answer is what? Now the answer will be, okay, now the answer will change like this. This is the only thing will change. Okay, so like this you can do. Okay, can you write the equation? If I have a basic block, then can you write the equation? Like, okay, all these things we have done, but can you write the equations? For basic block, how can you write the equation? Just tell me. For wait a second. Okay, so anyway, all these things we have seen. Remember this again, let me tell you, this is nothing but use in K, and this is nothing but def in K. Okay, so like this you can do. Okay, these definitions we have already seen. Okay, and these equations I told you, for basic block the same equations will be satisfied for the basic block. Okay, so that's all. Okay, and what are the applications of liveness analysis? If they ask you what are the applications, x equal to z, z equal to x. So Astitwa is asking this question. Can anyone tell me an answer for this? Okay, just tell me the answer for this question. If this is your basic block, x equal to z, z equal to x. So tell me what is use of B? In this basic block, what are the variables we are using and what are the variables we are defining? Just tell me. What are the variables we are using and what are the variables we are defining? The variables we are using is z and the variables we are defining is x comma z. Because you can notice this is use. This is used. You can notice. Yes or no? This is used in z. So you cannot note that x is not used. Not x does not belong to use in B. Why? Because x is defined before it is used. Because x is defined before it is used. Okay. So if you are standing here, then you can notice x is not used. Okay, and what are the applications? Okay, so what are these are the applications. If anyone asks you in the GATE exam, if they ask you applications of liveness analysis, so this I have already explained in the previous lecture. I have already explained. The answer is register allocation. Okay, so you can notice if a variable is dead, then you can take its if variable is dead, then reassign its register. So this is first application, register allocation. The second application is dead code elimination. So these are the applications. Okay, so everything we have seen. So did you notice one thing, that this is any analysis that you have. Remember, for any analysis, this is the situation that you have a statement. Okay, any analysis, whatever analysis you do. Okay, any analysis is basically like this. You have a statement. This is your statement. Any analysis is like this. This is a statement, and this is input, and this is input, and this is output. Okay, and can you notice that this statement will change something? This statement is going to change something. So I can say this statement is going to change something. I can say out is equal to function of in. Okay, so on this in you apply something you apply. Okay, this statement. So are you getting this point? For example, you can notice example, if you have this scenario, let us assume this scenario you have a equal to b plus c, or I can say a equal to b plus c. Now you can notice this is your out. Okay, this is your out of n, and this is your in of n. Now here you can notice that what is in of n? In of n is a function. Okay, in of n is function that depends on this statement, okay, and on this out. And we already know what is this function. You already know what is this function. This function is called transition function. Sorry, this is called some transformation or transition function. I think transformation. Okay, so this is transformation. Okay, anyway, so what is this function? You already know. What is that? That you already know, that is out of n minus def of n union use of n. Okay, so like this. So that is the reason this is backward analysis. Did you notice what is a forward analysis and what is a backward analysis? Let me tell you. Okay, remember, this is the definition of forward analysis. If they ask you what is a forward analysis, this is the definition. This is the definition, that you have a statement. Okay, so this is your statement n. So this is your statement n. Let's assume this is statement n. This is your in of n, and this is your out of n. Let me tell you what is the forward analysis. Forward analysis means that out of n is written as function of in of n. Okay, out of n is written as function of in of n. Is this clear? What I'm saying? Forward analysis, what it means, that this output, this out of n, you find it, this out of n you find from in of n. Okay, from these two you find this. Okay, so I can say, so this is a function of in of n, statement n. And what is backward analysis? If anyone asks you what is the definition of backward analysis, then let me tell you, backward analysis is like this. In the backward analysis, what you do, basically this in of n you write as a function of out of n. Okay, so this is your statement. This is in of n, this is out of n, and this is statement n. So here you can notice fn. So you can notice that this liveness analysis, that is the reason. So liveness analysis is backward analysis. Why? Because why this is a backward analysis? Because you can notice if you have a statement, then this is your in of n, this is your out of n, and you can notice that in of n is written as function of out of n. You can notice in of n, this is written as function of out of n. Correct? So this is what we do. So because you can notice in of n, that is equal to out of n. So you can notice this in of n is written as function of out of n, and out of n minus def of n union use of n. And what is out of n? This out of n is written as function of some other, like it's union of in of some other successor, not n but successor. Okay, so you can notice out of n is not written as function of, you can notice that out of n, outlive of n, you can notice that outlive of n is not a function of inlive of n. Correct? Yes or no? Outlive of n is not a function of inlive of n. Is not a function of inlive of n. Outlive of n is function of inlive of successors. Okay, but you can notice inlive of n, that is function of out n. So this is the definition of backward analysis, forward analysis. Okay, is this clear? So what is the definition of backward analysis? What is the definition of forward analysis? So this liveness analysis is backward analysis. Okay, this is your liveness analysis. Okay, so that's it. So that's it. you can see. So this liveness analysis and all the various and everything, like I can guarantee you, this is my personal guarantee, that if you got everything that I have taught in this lecture and in the previous lectures, then you can guarantee that you will not miss out any marks from this topic, from this code optimization in your GATE exam. 2 or 3 marks are guaranteed. Okay, because this code optimization is a new topic. They have added this code optimization in GATE 2021. So this is important and you can very easily solve the questions of code optimization. Okay, all the variations, everything we have done. Okay, so if anyone has any doubt, you can ask. I think everything is clear. You can do the homework that I have given to you. Okay, you can check them out. Okay, so now we will take a break, and after the break we will do some more things like available expression analysis, constant propagation analysis. Okay, so these things also we will do after the break. Okay, so remember, let me tell you after the break what is the, so after break we will do available expression analysis, available expression analysis. We will do common sub-expression elimination, common sub-expression elimination. In short, we call it CSE, common sub-expression elimination. Okay, and also we will do constant propagation analysis. This analysis we will do. Okay, so constant propagation analysis, available expression analysis, common sub-expression elimination, these things we are going to do after the break. Okay, if you have doubt in parsers, then you can ask in the parsing class. Okay, Nafis, so you can check the schedule, you can check the revision course schedule on the Go Classes website. Okay, so there you can check it out. There is a revision course, there is a revision class for parsing and lexical analysis. In that class you can ask all your doubts related to parsers. Okay, all your doubts. For example, what is handle, what is handle, what is viable prefix, LR0, LL1, everything, recursive descent parser, everything. Okay, whatever doubt you have, you can ask in that class. So we will take a break now. If anyone has any doubt, you can ask, else let's take a break and we will restart. So let me just tell you, we will restart at 10:30. Okay, at 10:30 we will start new session. Okay, so new live class. Okay, at 10:30. Okay, thank you everyone. See you at 10:30. Remember, this is very important that after the break we will do these things: available expression analysis, common sub-expression elimination, constant propagation. And these are very important because these are in the GATE syllabus. Okay, liveness analysis we have done and these are remaining. Once we do these, then code optimization is done. Okay, and remember, I will take all the variations, everything. So okay, so from these topics also I will do the complete all the variation and everything we will cover. Okay, thank you everyone. See you after half an hour.